Good afternoon, good evening, everyone. Welcome to our Grade 10 CSEC Mathematics Students webinar. Our focus on measurement. It's a pleasure to have you joining us. And welcome to those students who have joined us online. Also, welcome to those students who are joining us on YouTube. We're going to jump right in. So, of course, this is the Region 5 Mathematics Task-Based Assessment for Grade 10. I'm one of your presenters, Janice Simpson-Hales, and with me is Dr. Isilda White, who will also be presenting. All right, so I pray that we will have a successful afternoon. I invite you to participate actively in the session. By now, you should have gotten copies from your institutions of the worksheet that we have prepared, and that will be our point of focus for this afternoon. Can show a raise of hands in the show a raise of hand if you have already received the document, the task-based assessment document from your institution. For those who are joining us on Zoom, just raise your hand if you are in possession of a copy of that task-based assessment that was prepared. So far, I'm seeing one hand. Is that accurate data? All right. So it means that, a number of persons have not had prior access to this document. And so you are basically seeing this assessment, this task-based assessment for the first time. So I pray that we will be able to go through effectively and efficiently so that you can participate well. Before we get into the meat of the matter, I'm going to offer a word of prayer. Let us pray. Most righteous and heavenly Father God, I want to thank you for your loving mercies. As we go through this session, we pray, oh God, that you will open the hearts and the minds of the students who are present. Lord, give them a sense of clarity. Give them a sense of focus. I pray that their attitude towards the session will be impeccable and that they will garner much from having engaged with us. I pray for us as presenters that we will present with clarity and that we will ensure that whatever we do is to the best interest of our students. Thank you again, Lord. In your name I pray. Amen. All right, so our objectives for today's session, we have 15 objectives, and these objectives are spread across the task that you would have been exposed to, and our strand of focus is measurement. All right, can I see a show of hands of persons who are familiar with the strand measurement? Just raise your hand if you're familiar with the strand measurement and all the elements associated with this strand. And some of those elements are highlighted here in the objectives that you're presently seeing on the screen. So just to look at it carefully, you should be able to convert units of mass, length, area, etc. Thank you so much for typing the name of your name and the name of your school in the chat if you are not using a device that already has your name on it. Wonderful. So welcome one and welcome all. All right, we are going to be using the SI units of area, volume, capacity, mass, temperature, and time, having a little to do with the 24-hour clock and its derived quantities. So you'll encounter a number of these concepts in different ways. You should be able to determine the perimeter of a plane shape, calculate the length of an arc of a circle. So all of these things we want you to pull back into your memory so that you can actively participate. And if not, get your pencil and paper out, get whatever device you need to help you to refresh your memory of some of these concepts. We want you to be able to estimate the area of plane shapes, and to calculate the areas of polygons and circles, and also the sector of a circle, which means that you need to be familiar with the parts of the circle and so on. Want you to be able to calculate the area of a triangle. That's one of the most recent forms of area calculation you would have encountered in your early years. Want you to be able to calculate the area of a segment of a circle, the surface area of a circle, surface area of a polygon, not a polygon, surface area of a three-dimensional shape. All right, calculate the volume of solids, solve problems involving the relations in terms of time, distance, speed, estimate the margin of error. Estimation is a very good skill that you need to master as you work with the concepts relating to measurement, using scale drawings and so on to determine distances and areas, and ultimately to be able to solve problems involving measurement. And that's the most comprehensive of the objectives that you're being exposed to, because we learn all these things, but to what end? We want to be able to utilize these concepts to solve real world problems. And hence, that is why you are now engaged in working with a task-based assessment, because all of these concepts that you would have learned over time is now pulled into this task-based assessment for you to be able to see these concepts at work. All right, to see how is this applicable in a comprehensive way to help me to be a productive human being, to be able to solve everyday problems. All right, so tell your friends about the session. Look around. If your friend is not on the session, invite them to the session. Remind them that the session is on and that we are about to start. And so we want to have as many students as possible coming in, participating wholeheartedly in the session. All right. So again, we're working with the concepts relating to measurement. All right. Now, you're not able to unmute yourselves just yet. However, if a question is asked or there's a need for you to respond to a question, then you can raise your hands and you will be unmuted. All right, so that you can talk with us. But for the most part, we invite you to show a raise of hand in response to various questions. Remember, you can also utilize the chat so that you can share your thoughts there as well. And you will be able to interact with us via those means. All right. So mathematics on the farm. Show me a raise of hand of anybody who spent any amount of time on a farm. Anybody? You know, sometimes during Christmas holidays or summer holidays or so on, you visit perhaps your grandparents or some other relatives who are the proprietors of a farm or so on, and you perhaps have spent some time there. Show of hands, anybody? Or is this concept familiar to you? Are you hearing me clearly? All right, I see one hand. You've spent some time on a farm. All right. So I'm hoping that that experience that you would have gained there can help you to make the link with the concepts that you're going to interface with. So as we get right into it, on the farm, Mr. Clark owns a small farm, right, with 2 animal enclosures, one for cattle and one for pigs. Each pen has a layout with a feeding trough and a circular water trough inside. Both water troughs are filled from an external cylindrical water drum. Mr. Clark is planning upgrades and needs your help with measurements and cost estimates to efficiently manage the space and resources on his farm. All right, so the first segment of this presentation is going to be led by Dr. White. And so before we get into the meat of the matter, we're going to have a little brain teaser. And I like that this is being done online because you can see the picture very clearly. So you're going to type your answers in the chat. How many animals do you see in this picture? Type your answers in the chat. Just a numerical representation of the count that you have made of the number of animals that you are able to identify in this picture. I'm hoping that I would see the chat lighting up. How many animals do you see in that picture? And for those who are just coming in, please go ahead and type your name, if your name is not the name on your device, and the name of your school in the chat. All right, so I'm seeing some persons going as far up as 12, Dr. White. Some persons have 10, 7. So I'm seeing numbers coming in here. So
That's
far,
wonderful.
our highest, right? So far, our highest number is 12. All right, is that person being too presumptuous? Because others are being cautious by saying 7, 9, 10, etc. So, all right, so we have up to 10 as the another amount, but I've also seen up to 12. Is there any other number? Any other number? I'm seeing common numbers again of 9 and 7. Any other amount? All right, in the interest of time, we are going to look at how many animals, and let's see if we could point out a few of them, and you let me know if you agree. What's the trunk? The trunk of the elephant. Type in the chat. What animal is represented at the trunk of the elephant? Let's see. Type in the chat. Which animal do you see at the trunk of the elephant? A shark. All right, good. What about the mouth part of the elephant below the trunk? So shark, I'm accepting shark. Crocodile, very good. What about the elephant's ear? Or an alligator, that could work. What about the elephant's ear? A turtle, what about the elephant's eye? Fish, great. I'm sure you would have seen, tell me the animals that you're seeing below the donkey. Below the donkey. So you see a dog, a cat, a mouse. Very good. What about the ear of the donkey? What about the ear of the donkey? The ear of the donkey? All right. Okay. What about just above the donkey at the back near the tail of the donkey? What do you see? A fly. What about the tail of the elephant? Anybody keeping count of all the things that we have identified as snake? All right, great. Good. So would you be surprised to find out that there are actually 16 animals comprised in this picture? And so this is our solution. If you'd like to take a screenshot or so for your own interest, that's fine. But there are 16 animals identified here from such a simple picture, don't it? All right, great. So we're back to on the farm. All right. So in this segment, we're going to be looking at measurements and estimates. And I now hand over to Dr. White.
Good afternoon, students, and thank you for joining. And I know we are up for a good time this afternoon. So we're going to spend some time looking at measurements and estimation. So for part 1, I have a task for us to look at. And it says that Mr. Clark has recently expanded his farm with new pens for his cows. Given that the cow pen is 12 meters long and 8 meters wide, use a scale of 1 centimeter to represent 1 meter to draw an aerial layout of the cow pen on the grid below. I'll bring up the grid in a little while, but you can also, if you have your papers, you can find the grid on the second page. It continues, given that the cow pen is 12 meters long and 8 meters wide, use a scale of 1 centimeter to represent 1 meter and draw an aerial map of the cow pen, hence calculate the perimeter of the cow pen and then the area of the cow pen. Now, before we draw the diagram, the aerial diagram or layout, can you tell me some important points that we need to note in the statement, the first statement above? Is there anything of interest there that will guide us as we represent the cow pen on a diagram? Anybody, any answers in the chat, Mrs. Sales?
Not yet.
Let's look at the statement again and see if there are anything that's very important that we need to pay attention to before drawing or representing the cow pen. Anybody?
So Diana says length and width of the pen, and
Okay.
Miss Forbes says wide and long.
Okay. All right. Okay, thank you. So the word or the parts of the statement that I have that I think will help me with my diagram, you notice I underline 12 meters long, 8 meters wide. So that's important because it's telling me how to represent my diagram. Also, the scale is very important. 1 centimeter to represent 1 meter. That's very, very important. Okay, so I'm going to give you about 30 seconds to do a representation on your grid paper. Do a representation of the aerial view of the cow pen. And then I will project mine. Okay. Take into consideration while you're doing your representation, take the scale into consideration. 1 centimeter to represent 1 meter. I wonder if somebody in the meantime could tell me the dimensions of the rectangle, since we are using 12 centimeters, 1 centimeter to represent 1 meter, and the cow pen is 12 meters long and 8 meters wide. How would we label the diagram? How would we represent the diagram? What would be the dimensions of the diagram? Anybody, Mrs. Hales?
Not yet.
All right, let's take into consideration, it says 1 centimeter to represent 1 meter. And the cow pen should be 12 meters long and 8 meters wide. So my rectangle, because I'm using the scale 1 centimeter to represent 1 meter, my rectangle or my diagram would be 12 centimeters by 8 centimeters, because I'm using 1 centimeter to represent 1 meter. So when I represent it on the grid paper, it should look like this, with 8 centimeters wide and 12 centimeters long. Remember, that's a representation, that's a scale drawing, because we cannot represent 12 meters on the grid paper. But I could also give another orientation of the diagram. So here I have another diagram. Look at the orientation and look at my labeling. Okay? So any of these two would be fine. So if you did not have that on your paper, I don't know if you have your task sheet, you could make a sketch of this. All right, so we have done the representation. Now we want to talk about the area and the perimeter. Can somebody tell me from the grid paper, how can we find the area and how can we find the perimeter of this shape? And by the way, what shape is this? Put it in the chat. Anybody?
All right, some persons are saying a rectangle.
All right, so it's a rectangle. Thank you very much. Now, by looking on the grid, using the grid, how do we find, or how can we find the area of this rectangle from the grid? Put your answers in the chat, or responses in the chat.
All right, so a number of persons are saying length times width.
Okay, remember we're using the grid, we are not using a formula. How can we find the area from the grid? Can somebody tell me how what is area? What do we mean by area?
All right, so a number of persons are saying counting the boxes, counting the small boxes in the rectangle, counting the squares
Wonderful.
inside.
Thank you very much. So if we count the squares on the inside, that will give us the area. So we can count the number of number of boxes on the inside of the rectangle. Can somebody count that and tell us quickly how many boxes do we have on the inside? All right,
96, Diana says 96.
Okay, thank you very much, Diana. All right. And if we go to the blue box, the blue rectangle, would we get the same number of boxes? Yes or no?
S. Thompson says yes.
Wonderful. It's just a different orientation, but the measurements are the same. Now let's say the perimeter. How could we find a perimeter using the grid? And what is perimeter? Maybe somebody want to share. What is perimeter? Any responses? Put your responses in the chat.
Still waiting on a definition for perimeter. I'm sure they're coming up.
Okay.
The distance around the shape, says Diana.
Okay, so Diana, this is a rectangle. How do we go around? When we think of around, we think of circular, right, Diana? So how would we go around the shape? We'll be going around in a circle, correct? Could you say it another way, Diana?
All right, so there's a Forbes student, here by with a surname of Forbes. Says the total distance, just give me a minute, let me get back to that. The total distance around the outside of the two-dimensional shape. That's a definition coming from Forbes.
Okay, thank you, Forbes. Can we take one more, Mrs. Hills, before we move on?
Yes, Trishana Brown says perimeter is a total distance around the outside of a two-dimensional shape.
Okay. All right, students here are saying around, but when we go around, we are going in a circle, okay? So we want to say the distance along the edges, or we can say the borders, or we can say the boundaries of the shape, okay? So if you can see my cursor is going along the edge here. That is 12 centimeters, so it's along the edge here, and the edge here at the 8 centimeters, and so on. So it's along the edges, along the boundaries, or along the borders, not around. When we go around, we will be going around in a circle. But I know you have the idea, but we just want you to use the right math language. Okay, so what is the perimeter of this rectangle? Anybody?
Number of persons are saying 40.
All right, thank you so very much. So all we need to do is to count the number of boxes along the edges of the rectangle. Thank you. So let's dive deeper now. Now to do a representation that you're accustomed to outside of the grid paper, we have our rectangle measuring 12 meters by 8 meters. Now notice this is outside of the grid paper. So notice how it is labeled, not centimeters now, but meters. And that's important. So I give you two different orientation as well on for this representation. Okay. All right. So what shape is the cow pen? Anybody? What shape is the cow pen? Nothing in the chat, Mrs. Hales?
A number of persons are saying rectangle.
All right, thank you so much. So please note that in geometry, there's a specific formula for finding the perimeter and the area of rectangles. Now we are going to use the formula before we use the grid paper. So now let's look at the formula. Anybody can tell me the formula for finding perimeter? Let's take perimeter first. How do we find the perimeter of a rectangle? Using the formula.
All right, those fingers, I'm sure those fingers are getting ready to type. We're just waiting for them to type it in the chat.
Okay.
All right, so we have a response. We have 2 times open bracket length times width.
Okay. Can we take one more?
All right. Let's see, and it's repeated again for another participant.
2
So
times
2
length times width.
length times width.
All right. Does anybody know this one? Or is this correct? Would this be correct to find the perimeter of the rectangle? It's a yes or a no.
A number of persons are saying yes, miss.
All right, wonderful. What about this one? Does anybody know this one?
A number of persons are saying yes.
Is it the same as the first one? Just type yes or no.
Yes.
Wonderful. What about this one?
Number of persons saying yes and
All right,
say.
wonderful. Thank you so much. Oops, I did this too quickly, but it's up already. So for the area of the rectangle now, it's going to be the length multiplied by the width. Now for the perimeter, we can use any of these 3. We can choose any one. All 3 will give us the same answer. Okay, so let's now go find the...
Just to point out that prior to this, some of the responses regarding perimeter said P for perimeter is equal to 2 open bracket length multiplied by width.
Oh, length multiplied by width. Okay.
Right. So just want to see clarity on behalf of Callis, who would have typed that in the chat.
Okay, so let's go back. The person had 2 open bracket length times width. Please note that if we are using, that would be like the second formula. It's not length times width, but length plus width. Okay? The first one, 2 length plus 2 width. Or in bracket, we have 2L plus 2W. And the second one is 2 times, open bracket, it's length plus width. So we can add the 2, the length and the width, then multiply the answer by 2. But it's not a multiplication sign inside the bracket. All right? Okay, let's continue. So now we're going to substitute variables with the given values. So we are calculating the perimeter of the cow pen, and we're going to use, I'm sorry, this one is an error. I'm sorry about that. That should be 2L plus 2 open bracket L plus W. All right, please forgive me. The correct thing is right there. It's a plus on the inside of the bracket. Okay, so we are finding the perimeter. So it is 2 open bracket, sorry, L plus W. Please make the correction, students. It's 2 open bracket L plus W. So we know the dimensions. The length is 12, the width is 8. So we have 12 plus 8. Notice I add before I multiply. So 12 plus 8 is 20, and 2 times 20 will give us 40 meters. So the perimeter of the cow pen will be 40 meters. Any question from anyone? Everybody clear? All right, wonderful. Now let's go on to the area. How do we find the area of the cow pen?
Just a reminder to students, if you'd like to speak, feel free to raise your hands. And once we see your hand raised, then we will unmute you so that you are able to speak. All right?
Okay. Area of the cow pen. Can somebody tell me the formula for finding the area?
Well, a number of persons are saying length times width.
Okay, so the cow pen is length times width, and we know the length is 12 meters and the width is 8 meters. And remember, when we are when we are finding the area, we have our unit different from when we are finding perimeter. Notice here, the perimeter is 40 meters. Notice the area is 96 square meters. And notice I say the square before I say the meter. So it is 96 square meters. All right. Is everybody clear? Any question?
Remember to raise your hands if you have a question. If you're not clear, feel free to raise your hands. You'll be allowed to unmute so that you can speak. Taking it that everybody's clear, Dr. White.
Wonderful. Wonderful. All right, so let's continue. Okay, there's our rectangle. That's what we're working from. Okay, so part 2 now. It says, on the farm, the pen for the bulls is a compound shape made up of a rectangle and a semicircular section attached to one end. The dimensions of the rectangular section is 9 meters by 6 meters. And the radius of the semicircular section is 3 meters. And we're going to be using pi as 3.14 to aid in our calculation. Now, let me ask you, what in this task here for us to do, what are the important parts of this task? What is it that we really need to pay attention to? If you have your paper, just underline what you think is important that we really need in order to carry out the calculation. All right. So while you're reading it again, can you just put in the chat the important part, the most important parts of this task?
All right. Going back to the chat, I see responses such as semicircle, the values given, the formula.
All right. Thank you so much. Can we take one more?
Dimensions of rectangle and radius of semicircle.
Wonderful. All right. So I have one more question for you before we move on. What is a compound shape? Or maybe I should say 2 questions. The first one, what is a compound shape?
All right, so they are contemplating on that response, and I'm sure they're going to be typing momentarily in the chat.
Most definitely.
So somebody here, a Porus High School student, says, a compound shape is a shape that has 2 or more shapes added to it.
Wonderful. Thank you so much, Porus. All right, so let's move on to the second question. What is a semicircle? It says, and a semicircular section. How would we represent that part? Semicircular section. What would that look like?
All right, so Diana says half of a circle, and so does S. Thompson.
Wonderful. Thank you. So now we can proceed. So these are my very important words or phrases and sections of the question. These are going to help me to represent and to calculate. All right. I'm giving you 30 seconds to look at them. If you have your paper, go ahead and underline them. If not, maybe you can take a screenshot, and I'm sure you know how to navigate on the phone to get them underlined or highlighted. All right. So having said that, let us take the other part of the question. The first part says, make a drawing of the cow pen and show by calculation the total area of the pen. So from the information given, we're going to make a drawing, and then we're going to calculate the total area. And part B says, determine the amount of fencing needed in meters to enclose the pen. So we have two things to do. First thing we're going to do is to make a drawing. So I'm going to give you a few seconds or maybe about 30 seconds to do your drawing, and then I will show you what my drawing look like. Then we can do the calculation, okay? So that's it for now, 30 seconds. Label your diagram clearly.
And students, while you work, just remember, if you have a question or you'd like to share your thoughts verbally, feel free to raise your hands so that you can be unmuted, so that you have the opportunity to share or to ask your questions to gain the clarity that you need.
Okay. All right. Thank you, Mrs. Seal. So having said that, now let's look at the first diagram. Is this correct? Yes or no? Is that a clear representation of the information that was given? Yes, why? No, why?
Well,
So whether you say yes or no, you have to say why.
All right. So the poorest high school student says no, but as to why, that part has not yet been answered.
Okay, come on, Forrest. Let me hear you. Why would that diagram not represent the information? Or anybody else can help her. Why would that, or if you agree with her that it does not represent the information, could you share why?
All right, so a student is asking if you could go back to the instructions. And someone says, well, is it the same Porus High student? I believe so, says, in response to why, student says, because the semicircle should be 3 meters and the length is 9 meters.
Wonderful. Wonderful. Thank you, Ms. Porus. All right, I'm going to go back quickly, and I'm going to ask you to take a screenshot so you can have the question to work along with us. So take a screenshot, and then we can proceed. If you don't have a paper, just take a screenshot so we can work along. You can work along with us. All right, I think you would have taken the screenshot by now. So let us proceed.
All right, so Diana says yes, miss.
All right, great. So thank you, Porus. Anybody dispute that? Do you agree that it does not represent the information? I just need one more or two more persons to say yes or no.
All right, Diana says yes. So we're awaiting her reason for saying yes.
Yeah.
Again, students, just want to remind you that if you are on this session and you do not see your friends from your institutions or even other institutions who should be a part of the session, just send them a brief reminder and tell them that the session is on and that they need to be a part of it. All right. All right. So Diana says, same reason, the length is 9 meters while the radius is 3 meters.
All right. Wonderful. So let's take diagram 2. Would this represent the information?
All right, so far I'm not seeing a response in regard to the second diagram, but I'm sure that they're going to be typing momentarily.
Most definitely. They have been so cooperative.
I tell you. All right, so the Forest High School student says no. That
Reason?
diagram does not represent. And so we're
Why?
awaiting the reason for that one. And the reason offered is still awaiting. And other students, feel free to send your responses in as well, because we want a fulsome participation of all those who are in the session. All right,
That's right.
so Forbes says the length is 9 meters, while the radius is 3 meters. Forest High School student says in respect of the second diagram, the semicircle is attached to 2 ends instead of 1.
Okay, thank you so very much. Somebody's paying attention. Thank you. So let's look at the third diagram. Does this represent the information and why? All right. I know they're typing, Mrs. Hales.
They are. And I know that they're thinking as well.
Of course.
Because they're not sure if a fourth diagram is going to come up. So they're trying to determine if the third diagram is the diagram.
All right.
So we're giving them the opportunity to determine. So Diana says yes, and there is 1 semicircle. Forest High School says perfectly, because the semicircle is attached to 1 end and it has the correct length or width.
Okay.
Janelle Richards says yes, miss, because there is 1 semicircle instead of 2.
Okay. Thank you so very much. You're paying attention. Great. So now we can continue. Our diagram is clearly labeled. And so we are going to be working with diagram 3 as the students have said, that's a correct labeling. And they have given the reasons, so I don't think I need to go over them, right, Mrs. Hales?
Just a quick question, though, for the benefit of those who are not speaking.
Okay.
Why is it that the first diagram is different from the second diagram? What makes the first diagram different from the third diagram? Sorry. What makes the first diagram different from the third diagram?
All right, they're typing in the chat, I'm sure. So let's see what they will come up with.
All right, so somebody says the length is 9 while the radius is 3. What is that relationship? Why is it that the length cannot be 9 when the radius is 3? What kind of relationship is that establishing? Who wants to share on that? Says the radius is half the diameter and 3 meters is a half of 6 meters. All right, very good.
Wonderful.
And
Thank
therefore, the side opposite to that cannot be 9.
Oh,
Excellent. Thank you so much.
wonderful. Great. They're following. Wonderful. So we're going to be working with this diagram to do our calculation. So remember now, we want to find the total area of the pen. So we're going to find the area of the 2 shapes. Somebody said the compound shape is made up of 2 or more shapes. So we have 2 shapes that we're going to be working with, the rectangle and the semicircle. Okay? And we all remember how to find the area of rectangle, correct? Put it in the chat for me, please. Area of rectangle.
Hey, Diana says yes, yes.
I like that. Okay, area of rectangle?
It says length times width.
Wonderful. And we're going to take them one at a time. So let's do the rectangle first, since it appears first. So the area of the rectangle is length times width. What's it? Length, and what is the width of the rectangle?
All right, so they're going to be typing that shortly.
For sure.
So far they are aware that the formula is length times width.
Yes.
And so Diana says width is 9 meters and the length is 6 meters. So it's going to be 9 multiplied by 6.
All right, thank you so much. And when we multiply 9 by 6, what do we get?
54 meters is one
And-
response.
Okay, 54 meters.
And there are some responses coming in without any unit, and we are asking you to emphasize your units because that is important. So we don't just want to see 54. We need to know 54 what.
Right.
All right. So
So I'm
somebody
still
said
waiting for the
54.
correct response, Mrs. Sales. We haven't gotten that yet.
No, we're still getting 54 meters, Dr. White. So we're still waiting on them to catch on.
Yes, we need the unit.
Diana says meter square. So, all right. So Janelle says 54 meters square.
Mm.
Seeing the units coming on here. But I will read Forbes's response, 54 square meters.
Thank you very much, Forbes. Remember, we say the square before we say the meter. So it's 54 square meters. Okay? All right, so we have the area of the rectangle. Now we need to find the area of the semicircle. Anybody can help me to find the area of the semicircle? What would we need to know before we find the area of the semicircle? Before I go to the next slide, what would we need to know before we find the area of the semicircle? Anybody? Put your responses in the chat. We know you have fast fingers.
All right, so Moncrief says the formula.
All right, we would need to know the formula. The formula of what? Or the formula for what?
Forbes says the radius.
Radius of what?
Somebody says area of circle divided by 2. Somebody says the semicircle.
All right, the person who says area of a circle divided by 2, I don't know if you catch that name, Mrs. Sears. I would like that person to tell us why is it area of circle divided by 2?
All right, let me see if I catch that person. Just give me a second. Let me go up. So that is Deanna. Deanna, would you like to open your microphone? Would you like to speak to us as to how you came up with that? Deanna. All right, I'll unmute you, Deanna, so that you can share with us. All right.
Good afternoon,
Good
everyone.
afternoon, Deanna.
Okay, so I think it would be the area of the circle divided by 2, since a semicircle is half of the circle, and we're trying to find the area of the semicircle. So we'd find the entire area first, then divide the whole circle by 2 to get half of the semicircle.
Pat yourself on the shoulder. Wonderful.
Thank you,
You.
Deanna.
You have said it all.
Welcome.
All right. Very good. So we want to find the area of the semicircle as, is it Diana?
Yes, Deanna.
Diana. Okay. Does anybody know the formula for finding the area of a circle? Anybody?
All right, I'm getting back into the chat to see what is happening there. No response just yet. And that is in relation to the formula used to find the area of a circle. I'm not seeing a response in that regard just yet. I think they may have a challenge typing the square. But they're trying.
They can write the word square.
Okay, I'm seeing pi r. I'm seeing pi r squared. I'm seeing pi r square in words.
Okay.
So they're making an effort. And I'm seeing the representation in symbols coming out of Porus High School, pi r squared. And more persons are saying pi r squared.
All right. Thank you so very much. But just to quickly show you where pi r squared came from, if you notice, I have a circle here divided into 4 equal parts. Then it is opened up. If you notice, I still have the 4 different colors, 4 parts of the circle that was opened up. We know that from the center to the circumference, the straight line is a radius, okay? So notice where the radius is. Then we have this section here, but to make it a little clearer for you, if we cut them in small triangles, small rectangles, you see the small rectangles? Sorry, I keep saying rectangles. The small triangles, if you notice, we stretch it out and we get a rectangle. All right, how do we find the area of a rectangle again? Put it in the chat.
Times
How do
width.
we find length times width? So if we have this rectangle here, the last diagram down here, I don't know if you're seeing the cursor, but the last one with the tiny triangles, that's a rectangle. All right, what is the length of this rectangle? Anybody? What's the length of the last diagram with the tiny triangles? What's the length? Anybody?
Diana says R.
Okay, look again, Diana, and tell me what you see as the length.
Which is the longer side of the rectangle. All right, so Diana says pi R.
Wonderful. So that becomes the length of the rectangle. And what is the width of the rectangle?
Janelle Ray Richards says R.
Wonderful. So if we are finding the area of this rectangle, what would we multiply? You say it's length times width. So what would we multiply to get the area of this rectangle?
All right, pi R times R.
Wonderful. And that is where we get the formula from to find the area of the circle. So those persons who said pi r squared, this is just a little explanation to show you where pi r squared comes from. Okay, so I just write it out, pi times r, which is also the same as pi r squared. All right, wonderful. So because it's a semicircle that Diana, is it Diana, so explained so clearly, she said find the area of the circle, divide the answer by 2 because we are dealing with a semicircle. So the area of the semicircle is pi r times r, and we're going to divide that answer by 2 to get the area of the semicircle. Good? So let me give you 30 seconds to look at that again before I go to the next slide. Remember now we already found the area of the rectangular part. We now need to find the area of the curved part, which is a semicircle. All right, so let's go ahead and find the area of the semicircle. So it is pi r times r, or pi r squared, divided by 2. And so we are substituting the values for the variables. So pi, we said use pi as 3.14, and r times r is the same as r squared. We know that the radius is 3, so we have 3 squared. Can somebody quickly work that out and tell me what you get for your answer? 3.414 times 3 squared. Then we're going to divide the answer by 2.
All right, so Janelle Cardis from Forest High School says, let me go back. And Janelle Ray says 14.13 meters squared.
All right.
Janelle Cardis, let me go back to Cardis's response. She says, so is the area, this is a question, so is the area 14.13 square meters?
Oh, the person is asking.
Apparently so.
All right, so the area, yes, the area for the semicircle would be 14.13. It depends on how you round up, so that's why I have the 7 there. All right?
And that
so now we
symbol
want to
they may
find.
not be so familiar with. Sorry, Dr. White. I'm
Sorry?
just saying that symbol might be a little strange to them. I'm not sure if they're very familiar with that symbol.
Oh, in front of the
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 final
answer?
response, yes.
Okay, it's an approximate. We are saying approximately because pi is approximate. We have, we round it to two decimal places. So the answer is also approximate. Okay, so it is saying approximately 14.137.
Square meters.
Okay. All right. And so now we want to find the area of the rectangle plus the area of the semicircle because those two shapes make up the compound shape for the cow pen. Can somebody tell me what the final area is? We are helping Mr. Clark to set up his farm. So what would be the total area of the pen?
So Porus High School student says 68.137 square meters.
And can
Janelle
you tell us how you
Cardis,
got that?
Janelle Cardis says 68.14 square meters. S. Thompson says 68.13 square meters.
All right.
No one has yet responded as to how they were able to obtain that total. So we'll wait that response.
Yes, we wait another 30 seconds. And I know they are coming with the response. How did we arrive at that? All right.
Female, they're going to tell us, Dr. White.
Pardon?
All right, so Diana says 14.137 plus 54. S. Thompson says at the areas of the two shapes, Porus High School student says 54 meters plus 14.137 square meters.
Okay.
Remember,
all
Porus
right.
High, its areas in square meters. So both units should be square meters.
Right.
Just to highlight
So,
that.
okay, thank you. So we add the two areas, and that will give us a total area of the cow pen. Wonderful. Students, you are doing very well. So let us continue. Now, the other part of the question says we are to determine the amount of fencing needed in meters to enclose the pen. What are we actually finding here?
Diana says perimeter. Janelle Cardis also says perimeter. First high school student says the perimeter. I think we're going to get to a point where we are going to ask students specifically to respond so that no child is left behind.
That's true.
Right?
Wonderful.
Let's find out from McLean. McLean, can I unmute you for a second? Can you tell us what concept does this part of the question imply that you're going to be working with? What math concept are we looking at? It says determine the amount of fencing needed in meters to enclose the pen. What math concept are we talking about here? McLean, I'm going to unmute you. Let's hear a response from McLean. All right. McLean is not able to respond. How about Lishania Dennis? Dennis, would you like to respond to that? All right, thank you for that, McLean. I understand. Dennis, are you able to unmute? Would you like to share with us? Dennis? Remember, once you're a part of the session, we want to see you participating so
Exactly.
we can identify the extent to which you are following. We don't want just to hear from some students, we want to hear from as many as possible. Devonnie Smith. Devonnie Smith, would you like to share? I'm going to attempt to unmute you, Devonnie Smith. Would you like to share? All right. All right, we're not able to unmute.
Miss,
Just now? All right, Devonnie, go ahead, Devonnie. We're asking you, what concept do we need in order to determine the amount of fencing needed in meters? Are we going to be finding the length, the width, the area, the perimeter, the volume? What are we finding in this part of the question? Share with us.
Miss, is it the perimeter?
All right. Can you briefly tell us why you're saying it's the perimeter?
Miss, to find the amount of fencing needed,
Mm-hmm.
In meters, you need to find the perimeter to find out how much fencing you need to fence around the pen.
The boundary, along the boundary of the pen. All right.
Yes,
Thank you so
miss.
much, Devon. Thanks so much.
You're
All
welcome.
right. Thank you very much, students. So back to our shape, or our diagram, I should say. So as you have said, we are finding the perimeter. And we have two shapes, again, the rectangle and the semicircle. How do we find the perimeter of this rectangle right here in front of us? Any responses in the chat? We want the perimeter of this rectangle right here.
All right. Cardis says add all sides.
All right, say a little better for me. What side? Send me the measurement of the sides.
No response yet. Awaiting that response. All right. I think Cardis is saying, is that a typo, Cardis? Would you like to retype it? All right. Thank you so much. So Cardis says 9 plus 6, 9 plus 9 plus 6.
9 plus 9 plus 6. But let me just ask a question. The rectangle is, the length is 9 and the width is 6. So it has 2 lengths and 2 widths, right? So I'm hearing 3 measurements from, I don't remember the name. You said 9 plus 9 plus 6. What happened to the other 6? Why aren't you adding the other 6? Anybody can answer. You can put it in the chat, or if you want us to unmute you.
All right. Support High School student says the other width is inside of the shape.
Wonderful. Thank you very much. And we say perimeter is along the boundaries, along the edges, along the borders of the shape, not on the inside. So the measurements of the rectangle that are on the outside is 9, 6, and 9. Wonderful. Good. Good job. So it's 2 lengths plus 1 width. Now, for the semicircle, how are we going to find the perimeter of that part? Any ideas? Anything coming up, Mrs. Hills?
Yet. All right. So Cardis says pi times diameter divided by 2.
And what are we finding there? You said pi times. Can you explain where you got that from? Pi times diameter divided by 2?
All right, Cardis, I'm going to attempt to unmute you so that you can explain yourself. All right, Cardis, inviting you to accept the invitation to be unmuted so that you can share. Go ahead.
Miss, you came by First High School and you explained it to us because
Okay,
how we got the
so
pi,
explain it to us now.
how we got the pi is because they said that we're supposed to use pi equal 3.14 and the diameter is the length the length from the center to one end of the circle, and we
Okay, I
only
was
got
waiting for the circle.
the length of 1.
And what? I didn't hear the last
So we
part.
only got 3. So we would have to find the other half of the circle, which would be 6. And then we're going to divide it by 2.
You lost me along the way. Would you like to repeat what you said? I kind of got a little lost along the way. Do you mind starting again?
So, Miss, I'm not sure how to explain the diameter part, but I got how we got the pi and the divided by 2.
Okay, you understand the pi and the divide by 2, but not the diameter.
Yes, miss.
What's the diameter of the circle?
Of the circle,
Uh-huh.
as in the entire circle or the half of
The
circle?
entire circle.
6.
Okay, so what's the diameter on the whole circle, on the half of the circle?
3.
What's the difference between radius and diameter?
So 2 radius makes 1 diameter.
Or 2 radii. Okay, can we find 2 radii on half of the circle?
No.
Look at it. Would you see this dotted line?
Yes, miss.
Would it represent a radius or a diameter?
A diameter.
Okay. All right. All right. Thank you so much. I'm not going to grill you anymore. I'm not going to grill you. You have said enough, and I think you did well. All right. Can we take another one? Oh my, I clicked and it came up. All right, so it's pi times the diameter, and we are dividing by 2. But I really wanted to hear the explanation. What is pi times diameter? What are we finding here? Pi times diameter, what does it represent? Anybody? What does the pi times diameter represent? Anything in the chat, Mrs. Hales?
Janelle Ray says a full circle.
What of a full circle? Can't be just a full circle. It must be something we are finding of the full circle. What would that be?
Again, students, please be reminded that you are finding, all right, Janelle said it, the perimeter.
Right, the
And
perimeter.
Forest High School student says the circumference.
All right, so let me ask you, what is the difference between perimeter and circumference? Are they the same or are they different?
In relation to the circle.
In relation to the circle, thank you. Anybody?
All right, Janelle says they are the same.
All right, thank you, Janelle. So they are the same. So if we say find the perimeter of the circle, find the circumference of the circle, we're asking the same question, right? So the perimeter of the circle is pi times diameter. So because we are finding half the perimeter of half of the circle, we divide the result by 2. Okay? So we know that somebody explained this quite clearly. We have 2 lengths of 9 on the rectangle. The 2 lengths are 9 centimeters, and then 1 width, because the other width is on the inside, which we do not count. So we have the 2 times 9. Then we're going to add the 6, and that would give us the perimeter of the circle. Sorry, the perimeter of the rectangle. And for the semicircle, we are using the pi times the diameter. The diameter is 6. And then we're going to divide our answer by 2, because this pi times diameter represents the full circle. Can somebody work that out quickly and tell us what's the perimeter of the rectangle? What's the perimeter of the semicircle? Let me give you a chance to work that part. Perimeter of the rectangle?
Well, Janelle Cardis says 9.426 square meters. And as she's saying, that is for the semicircle.
Okay. So what would be the perimeter of the rectangle?
All right, no response just yet. Janelle says 24 meters.
Okay, wonderful. And the first person who said 9.42, that's for the semicircle, that's correct. And if we total that, we will get 33.42 meters. Remember, we are finding perimeter, so our unit is meters, not square meters. Okay?
Approximately.
Approximately. And notice I have the symbol there. So it's approximately because again, we use pi and we use an approximate value. All right. So the amount of fencing needed to enclose the pen will be approximately 33.42 meters. And notice how I write my final answer. I write it in a sentence. It says determine the amount of fencing needed. So I say the amount of fencing needed to enclose the pen is approximately 33.42 meters. It's good when you can write out your responses like this, students. All right. So we have more work to do on this question to help Mr. Clark. Any question? Is everybody clear? Anything not so clear? All right, that sounds like move on. So let's continue. Now we're going over to part 3 of the paper for those who have the paper. So this one now, it says the water trough in the cow pen is a circular basin with a radius 0.5 meters and a height of 0.75 meters. Now we're going to calculate the area of the base of the trough, and we're going to use pi as 3.14. And B says, what distance along the circumference of the water trough does one cow have such that 4 cows can drink at the same time if the trough is divided into quarters? Part C, name the shape at the base of the water trough from which each cow will drink. And part D says, calculate the area of the shape in part C. Take a screenshot so you can follow along, although I will have the different parts of the question as we work them out. But I'm advising you to take a screenshot for those who do not have the task on paper. So in 5, 4, 3, 2, 1. I know your fingers are fast, so you would have taken the screenshot. So let's go. So here now, the information given says that the water trough in the cow pen is a circular basin. What solid would that be? What would that represent? It's a circular basin. What solid would we use to represent that? We're not there yet, but I just want to ask you that question.
Number of persons are saying cylinder.
Okay, wonderful. Thank you. We're not there yet, but I just want to bring that out early. Now we're going to calculate the area of the base of the trough. What shape would be at the base?
Still awaiting responses. S. Thompson says circle.
Wonderful.
Says circle as well.
It's a circle. So there's my circle. What is the radius of the circle at the base? Anybody?
S. Thompson says 0.5 meters.
Okay, wonderful. So that's 0.5 meters. Now we're going to calculate the area of the base. What shape are we finding the area of?
Somebody says cylinder. S. Thompson and Janelle Ray says cylinder.
Remember, it's the base now. It's at the base. What shape would be at the base of the cylinder?
All right, Diana and Moncrief says circle.
Wonderful. Now, how do we find the area of a circle? Anybody remember?
All right, Janelle Ray says pi times diameter.
Pi times diameter. Can we say it another way? Is there another way we could say it?
S. Thompson says pi r squared.
All right. Seeing that we are given the radius, we're going to use pi r squared. Okay? Remember now, for the area of the circle, it is pi r squared. All right, so let's go. So recall the formula. The area of the circle is pi r squared. All right, it's the radius that we use to find the area of the circle. All right, so the area at the base of the trough would be pi r squared because it is a circle. So we use the formula pi times r squared. And can somebody work that out and tell me what's the final answer? Use your calculator. 3.14 times 0.5 squared. Any response?
All right, so I'm seeing 0.785 square meters, and Janelle Ray says 78.70. Didn't mention a unit, Janelle.
0.7 and then 78.7.
Yes.
One more and then we will reveal the answer.
All right, so let's see one more response.
That is different from those
Response.
two.
That is different. Well, one came in, but it is the same as another response. It's 0.785 square meters.
All right. After you multiply, you should get 0.785 square meters. Thank you for those who have that as their final answer. If you didn't get it, you can work it again, and you should come up with 0.785 square meters. Wonderful. So we have answered the first part of the question. So now let's move on to part B. Part B says, what distance along the circumference of the water trough does one cow have such that 4 cows can drink at the same time if the trough is divided into quarters? Notice I divide my trough into quarters. So 1 quarter represents 90 degrees, as an angle of 90 degrees, I should say. Sorry about that. So 1 quarter as an angle of 90 degrees. What would be the other quarter, the angle for the other quarter? The second quarter, what angle would it form? Anybody? Can I get one response, then I move on? No response?
All right, right angle 90 degrees says S. Thompson. Diana says 90.
Wonderful. Thank you so much. So now, what fraction of this is each part of the circle? Each quarter of the circle, I should say. What fraction is each quarter of the circle? I'm sorry.
Seems like you gave it away.
I gave it right away.
Diana caught on and said a quarter, miss, a quarter.
I gave it right away. I'm so sorry.
MJ
All right, that's a
also
quarter.
says a quarter.
Yeah, you deserve one answer. You have been working hard. So let's recall and apply the formula. So we said the circumference of the circle is 2 pi r, or pi times diameter. Notice the circumference, not the area. The circumference is 2 pi r, or pi d. So we're going to apply this formula to finding, what did it say we have to find? We have to find the distance along the circumference of the water trough. Sorry, what distance along the circumference of the water trough does 1 cow have? So it means we are only looking at one section. So each cow would have a quarter. Okay, so if we are finding a quarter of the circumference, how would we apply that using the formula? We are finding for 1 cow. Each cow is given a quarter. What formula would we use to find that distance? Anybody?
All right, so Diana says pi r, 2 pi r divided by 4.
Pat yourself on the shoulder. Very good. Because we are taking a quarter of the circumference. We divide it into 4 equal parts. We're taking 1 part. We're dividing it by 4. All right? So we divide it by 4. Very good. So let's continue. So we know that the formula is 2 pi r. So we have 2 multiplied by pi multiplied by r, which is the radius. Then we're going to divide that answer after we multiply the numerator. We're going to divide that by 4, and that will give us 0.785 meters. Notice no squares on it because we are finding perimeter. Remember, circumference synonymous with perimeter. Okay? So there we would have it. That would be the distance that one cow would need to use. And say I use my arrow to show from A to B, that would be the distance for one cow. All right? Good, everybody? I take it everybody's following. So let's move on. And if we round it to 2 decimal places, we would get 0.79. All right? Great. Now let's continue. Now, the other section says we are to name the shape at the base of the water trough from which each cow will drink. What's the name of the shape in green? Anybody? If we take that out of the circle, what would be the name of that shape? It's in green, the green section. What's the name of it? Anybody? Anything, Mrs. Hales? All right.
So sorry about that. Not yet. Porus High says a quarter circle.
All right. So the name for this section that is in green would be a sector. Notice where the sector is. It is bounded by 2 radii and an arc. The arc is from A to B. So the sector is bounded by 2 radii and an arc. Okay? So the question was, what do you know about the sector? I just explained it. It is bounded by 2 radii and an arc. So they say we are to name the shape. That's all we need to do. Now part D says, give us another task to do. It says calculate the area of the shape in part C. What was the name of the shape again? Anybody remember? What's the name of the shape? Green.
They're saying a sector, a sector,
Wonderful.
a sector.
Wonderful. So it's a sector. Now we're going to find the area of the sector. So what is the angle measure of each sector on this circle? What is the angle measure of each sector on this circle? Anybody? No response?
Well, I'm seeing a number of 90 degrees in the chart.
Wonderful. 90 degrees. It's divided into 4 equal parts. Remember, the entire circle is 360 degrees. If it is divided into 4 equal parts, then each section would be 90 degrees. So let's recall and apply the formula for a sector. So the area of a sector would be the angle that is given divided by 360. And we are multiplying it by pi r squared. Anybody can tell me why we are multiplying that by pi r squared? Anybody?
Still waiting.
Oops, I went too quick. Sorry, my finger just hit the thing.
Okay.
Why pi r squared? Anybody? What does pi r squared remind us of? What did we use pi r squared to find? All right, you're not going to sleep on me, right? I know you're there. Say something. Pi r squared, we just use it. What did we use it to do?
The area. Somebody says because we're finding the area.
Area of what? Come, students, I want you to remember your formula.
Somebody
right.
says, a number of persons are saying the circle and one is saying the sector.
All right, the sector is a part of the circle. Remember, the sector is inside the circle. So it's a part of the circle inside the circle. And so because it's a portion of the circle, we use a pi r squared because inside the circle is pi r squared. So this angle over 360 is a fraction of the entire circle. So we are finding a fraction. That's why we have angle over 360. We are finding a fraction of the entire circle because the sector is a fraction of the entire circle. Okay? And so the angle that is represented is 90 degrees. So 90 out of 360. So this is just one part of the circle, one portion, 90 degrees of the entire 360 degrees. And so we multiply that by pi r squared because remember, inside the circle, to find the area inside, it is pi r squared. So we are taking a fraction of the inside of the circle, of the area of the inside of the circle. I know I said quite a mouthful. I hope you understand what I just said. All right, so if we do our calculation, we would end up with 0.196 square meters, and we can round that to 1 decimal place to 0.2 square meters. Let me know if you have any question.
All right, no questions yet.
All right, so let's continue. Okay, so just a little reinforcement. Why might a farmer divide the water like this? Why would he divide it into 4 parts?
All right, still waiting for responses.
If you are following me, tell me, why would the farmer divide the water like this?
To equally feed the 4 cows.
All right,
Says
I'll accept that because we were talking about 4 parts, right? Now, how could knowing the sector area help in feeding or watering the livestock? How could that assist Mr. Clark?
To make sure the water flows evenly throughout each part.
I'll accept that. And also to know how much water to order because you would know the amount of water that is needed for each section. And you want to equally divide the water among the cows. All right, very good. Now part E says, make a sketch of the curved surface of the water trough and then determine its area. Now, if you look at this representation, the first one is a rectangle. Let's call it a blank sheet of paper, like printing paper or your folder leaf. If we curve it around like this, what do you notice? Look at the first diagram and the second diagram. What do you notice when I curve the paper around, looking like the middle one? What do you notice? Anything? We have a blank sheet of paper. We twirl it around, just make a curve. It looks like the middle one. Look at how the plain sheet was labeled. Look where the B is. Look where the L is. What do you notice on the middle diagram?
Devon Smith says it forms a cylinder.
Wonderful.
Says process of becoming a cylinder.
Wonderful. I like that. The process of becoming a cylinder. Very good.
Well expressed.
Well expressed. Now tell me a little bit more. Look at the labeling. Look at the labeling on the plain sheet and look at the labeling on the one that is forming or in the process of forming a cylinder? What do you notice? Look where the B is on the plain sheet. Look where the B is on the middle one. What is that B on the plain sheet saying? What is the B on the middle one showing? What is the L on the plain sheet showing? What is the L on the middle one showing? All right, let me help you. If you notice that for the first diagram, the plain, let's call it a plain sheet of paper, the B is the width of the paper. The L is the length of the paper. And to find the area of this rectangle, we would multiply the length times the B, which would be the breadth or the width. Okay? Now, when I curve the paper around, the width of the paper becomes the height of the cylinder that is being formed. So the breadth or width of the paper becomes the height of the cylinder being formed. The L, which is the length, becomes the, what is part of the cylinder name? This curved part around here. So anybody can tell me what this curved part represents on the cylinder before I say it? It is even clearer in the last one. What does it represent? The what?
All right, still waiting on a response in the chat. Diana says the base.
Okay, it's the base, but what shape is formed at the base? What shape is formed at the base of the cylinder?
Terrian Tour says a circle.
All right, wonderful. It's a circle. So what is the outer part of the circle called?
Around the boundary.
Boundary. Can you give me another name? All right, it forms a circumference. So the length of the
Devon Smith says, is it the circumference?
Wonderful, Devon. Thank you. So the length becomes the circumference of the cylinder, and the breadth or width of the paper becomes the height of the cylinder. So how would we find the curved surface of this cylinder? Remember, the length becomes the circumference, the width becomes the height. Anybody can tell me? For the area of this plain paper, is length times width. So if we want to find the curved area, we call it the curved surface area of the cylinder. What would it become? Remember, down here at the bottom is the circumference, and the B here is the height. We are still multiplying length times width, but this time it's not length, it is the curved part, which is the circumference. So how could we find the curved surface area of the cylinder? Anybody?
So Janelle Ray says circumference times height, and Diana says height times circumference.
Pat yourself on the shoulder. Wonderful. Very good. So it's going to be the circumference multiplied by the height. I go through all of this because that's what we're going to be using right now. So this would be the sketch of the trough. The information said it is 1.2 meters diameter. It has a diameter of 1.2 meters, and it has a height of 0.6 meters. So here we have it, and we label the diagram. So if the diameter is 1.2 meters, then the radius is half of the diameter, which is 0.6 meters. Good? So now we want to find, well, we just say it is a cylinder, what shape it is. It is half of the cylinder, because the full cylinder would, be a little higher, and it said something about half of a cylinder earlier. All right, so what does a curved surface area mean to half of a cylinder? This is half of a cylinder. What does a curved surface area mean? What are we actually going to be finding if it is half of the cylinder? Anybody? Come on, we have been doing this throughout. This half thing. Let me give you a little clue. Half of a circle half of a, what was the other one? Yeah, half of a circle, half of a circumference. Now we have half of a cylinder. So what are we going to be doing when we find the curved surface area? Anybody?
Janelle Ray says semicircle times height.
Semicircle times height. All right. In the same way we found half of the circle and half of the, when we were finding the curved part at the end of the rectangle, we found half of the circumference. It's the same thing we're going to be doing. We're going to find the curved surface area, but we're going to take half of it because it's half of a full cylinder. All right. So there we have our shape again. We're going to be using this one and to find the curved surface area. And we did say it is going to be the area of the circumference, which is 2 pi r. Sorry, not the area. The circumference of the circle, which is 2 pi r, multiplied by the height of the cylinder. So that will give us a curved surface. All right. So let's put that on paper now. So here we have it. Because the circumference is 2 pi r, we have it right there. And then the base, or the, sorry, not the base, the breadth becomes the height of the cylinder. So we want to find the curved surface area of the trough. Let's apply the formula. For the full closed cylinder, the surface area will be the area of the curved surface, which is here, plus the area of the two circular cross sections, that would be the top and the bottom. So the full cylinder, full closed cylinder, like a tin of condensed milk or a tin of beans or something like that, it has cover at the top and the bottom. So we have those two circular cross sections. Then it's the area of the curved surface, that's the curved part that we just looked at in the blue, to add to that. So the full cylinder is 2 pi RH. 2 pi RH, remember, this is the 2 pi r times the h, the length of the paper times the width of the paper. 2 pi r times h, that gives us the curved surface. And then for the top and bottom, if it is closed, would be 2 times pi r squared. Because one circle would be pi r squared. So 2 circles will be 2 pi r squared. All right? So what we really need here, look at it carefully. 2 pi r, okay? Length times width of the paper, circumference times height of the cylinder. So because the cylinder is open, the open part with one end, because the cows are drinking from the trough. So one end has to be open and one closed. That's how we're going to get the water to stay inside the cylinder. All right, the cylindrical trough. It must have a bottom, it must have a base, it must have somewhere where the water stays in. So we're going to have a base and we're going to have the curved surface. All right, so we're going to use a formula for finding the curved surface. Look at this blue here. For the curved surface, it is 2 pi RH. But because it only have one base, one part at the bottom, because the other part is open, we use only one of the pi r squared. Because up here, where we have the 2 pi r squared, this is for top and bottom. So we don't need top and bottom because they must drink the water. So we're going to open it. So one section will be open, the top will be open, but the bottom will be closed. I hope I am making sense. I hope you are understanding. So the curved surface area of the trough would be 2 pi radius times height. That's the curved surface. 2 pi RH. That's what is circled here. Okay? 2 pi RH. When we multiply all of that, we get 2.26 square meters to 2 decimal places. This is just the curved surface. 2 pi RH. Multiply that, we get 2.26 square meters. So that gives us a curved surface area of the trough. Take a screenshot or write it on your paper if you have a paper. All right? All right, I'm giving you like about 10 more seconds. So the curved surface area would be 2 pi RH. 2, then pi, then the radius is 0.6 because the diameter, earlier on, we said the diameter was 1.2 and we said the height was 0.6. So let's continue. So here we come now. It says water is supplied to the farm from an external cylindrical drum that has a capacity of 3,534 liters. So how many full circular basins can this drum supply? And we are to give reasons for our answer. But we need to know that a trough can hold 339 liters of water. So let's go again. The water is supplied from an external cylindrical drum that has a capacity. This is the capacity of the external cylindrical drum. But one of the troughs that feeds the cows can hold 339 liters of water. Before we do our calculation, we need to know what capacity is. Can anybody tell me what is capacity? What is capacity? And you're also going to tell me what is volume. What's the difference between capacity and volume? So tell me what is capacity, then you tell me what is volume. Then we can see the difference between the two.
So Janelle Ray says maximum.
Maximum. Can you say a little bit more?
That was in response to your question about capacity.
Yes, I realize that. But can you say a little bit more? You say maximum. Maximum what? What do you mean? What do you mean?
Marlon says volume is the amount of water.
All right, so one say capacity is maximum and the other say volume is amount of water. Why are you giving me the answer in pieces? You are doing so well, but I want you to say it properly. Come.
So bear in mind, those are two different students.
Yes, I realize. The person who said capacity is maximum. Say a little bit more. Now you're getting there, but I want you to say it a little better so that the others on the meet will understand what the difference between capacity and volume. Would you like us to open the mic? Say yes or no in the chat.
All right. Janelle Ray says maximum is the capacity of an object, while volume is the amount of water.
All right. And
Terrian Turner says the maximum of amount. S. Thompson says capacity is the amount that can be held or be held. I'll use that. And volume is the amount that is inside.
All right, you have a good idea of what it is. Very good. So capacity is the maximum amount that a container can hold. And of course, the last person said volume nicely is the amount that the object actually occupies, that is in it right at the moment. All right? But can capacity be equal to volume? Yes or no? Yes or no? Put that in the chat. Yes or no? Can capacity be equal to volume?
Marlon says no.
So Marlon, if you have a water bottle and it's filled to capacity, no air, nothing can get in it, what will be the volume of water in the bottle? Would it be the same as the capacity? Yes or no?
Janelle Ray says yes.
Yes, all right, good. So capacity can be equal to volume. But remember, the volume now is how much is in it at the time. Capacity is what it can hold. The maximum, somebody said the maximum amount that it can hold. Let me use that word. So it says now, how many full troughs can be filled? Okay, so we know that one trough hold 339 liters and the external container hold 3,534 liters of water. So we want to know how many troughs can be filled. So we divide the total amount of water from the external cylinder by the amount that one trough can hold. And when we divide that, we will get 10.443 liters. So only 10 troughs can be filled. Why did I say 10? Can we fill with a fraction? No, we can't fill a fraction. The 0.43 will not fill a trough. So we can get 10 full trough. So the drum can fully supply 10 troughs because the 11th drum would not be completely filled. All right. Take a screenshot or write that down quickly and let me know if you have any question. Any comments? All right. Let's continue in 5, 4, 3, 2, 1. Good. So I know you have taken your screenshot. So let's continue. Now here is my question to you. I've been doing most of the talking. Why can't we use 0.43 liters of a trough? That was the amount that was left over. Somebody can tell me that quickly? It's a recap. Why couldn't we use this? Why we said only 10 troughs can be filled? Recap.
All right,
Anybody
Janelle
remember what
says,
I... Go ahead, Mrs.
Janine
Hill.
says, rounding to the nearest whole number, it would be a fraction of the object.
Hence, you give me part of the answer. You didn't say everything. It would not fill the trough. All right, great. So how would you plan water usage knowing this limit? Anybody? Anybody?
No additional response just yet.
All right. While you think about that, I'm going to hand over to Mrs. Hales at this time.
Thank you. Thank you so much, Dr. White. All right, students, our time is far spent. So we are going to take a break here and we are going to continue in part 2. So segment 2 will be done in part 2 of our session. Please jot down this date. It's going to be on the 17th at 5:30 p.m. So we're going to continue the session on the 17th, that's next week, Tuesday, at 5:30 p.m. To finish up because our time is far spent. And we want to make sure that you are operating at your full capacity when you come back. So we're going to have the session in a part 2